Thank you very much, Francisco and Carissa, for getting us started. And I want to just express my appreciation for the invitation to come share views with you, to share some of the work that I've done, including collaboration with some UC Davis colleagues. And I'm really honored that Professor Alisa Kendall could join us today. And we've known one another for some time now in the UC system. This is not a small topic of research and education, but most of the people who work in the field kind of know one another. And it's really a privilege to be part of that group. So thank you, Professor Kendall. And to everybody else in the audience, I'm pretty easygoing, although you can also rile me up if you bring up interesting questions, but I invite you to try to rile me up with questions. And hopefully my presentation will be clear and we can continue the conversation even beyond today. So we were joking earlier before 3 p.m. that we live in interesting times, and so far nobody's come after the word justice. When they do, then we know we've moved to a different country. But things like equity and diversity and inclusion are under the gun, so to speak. But today I'm going to talk to you about environmental justice agenda for the electronics revolution. I picked the words carefully, and I'm going to try and convince you that we are well past the beginning of an electronics revolution, but the landscape keeps changing. AI is the new revolution. But the environmental justice has always been with human societies and how we make sure that equitable benefits across populations and risks that are not partitioned to one population or another will probably always be with us, but we hope that we continue to move toward fairness and justice with every effort that we can muster. So I've like to generally divide my presentation into sections. I'm glad that you allocated an hour and a half. I try to be as concise as possible, but understandably, I'm hoping we have more time for questions and discussion. I look forward to learning more about your own views and work, as I hope I can present mine. So I'll give a background, which I call Chasing Justice at Intersections. I know that this is an energy oriented group, so I just wanted to tell you a little bit about my own history, how I got to the topic of environmental issues and justice. And I think understanding that justice issues don't exist in silos is really the message there. And then I'll go to how that informed my work on electronic waste and environmental justice issues associated with e-waste. And even though electronics have revolutionized the way society is organized worldwide and interact and conduct business, there are still some emerging issues that we have to continue to confront and walk through. And hopefully I will talk a little bit about some of the action items. I think when we talk about justice issues, it always sounds like we're complaining and we're pointing out problems. And I've always tried to say that there are ways that even though we point out those problems, um, just the nature of those problems should also guide us in terms of solutions. So how we can proceed from knowing that changes needed to action is important. And hopefully we'll conclude with some thoughts. If at any time during the presentation uh, you have clarification questions, I'm sure the moderators, Francisco, can alert me if I don't see you right away. Okay, so chasing justice at intersections. I think the word justice is being used now for energy, environment, climate, and in public health, we just can't get away from trying to make sure that every member of a population has equal opportunities to pursue health and to benefit from society's investments in health. And when we see that there are gaps that are not being compensated, then we use the term justice as a remedy. I grew up in Nigeria, and this is my first publication ever. I was very lucky to work with a strong mentor, Odeyemi, and I was earning my master's degree in microbiology. And at the time, the energy industry in Nigeria was already on its way up. Agriculture and farming was the base of the economy until petroleum was discovered in 1956. And that was just before the British left as a colonizer. And soon after, if this oil industry had been established before all the advocacy to become independent, probably the British will still be there, and we may be in the same situation as perhaps South Africa, where independence was prolonged for so long. But I was studying microbiology. We were interested in pollution, mostly of the water resources in the Niger Delta, uh, and a field trip quickly revealed that biological pollutants were a small part of the problem because the water was covered with oil sheen, and petroleum eventually became the major economic driving force for the country, contributing more than 90% even today. And agriculture has been left behind. And a lot of the concerns with the economy in the country is associated with this lack of diversification. So that was my introduction to research, and I quickly decided I wasn't going to go into medicine because I wanted to spend time out in the field and take water samples and talk to people. But petroleum in Nigeria, as you can see from these maps, it's the biggest resource in Africa in terms of oil and gas reserves and mining. For many years, Nigeria was part of the OPEC, oil and petroleum exporting countries. And it had been sort of spared from some of the political upheaval that would destabilize Libya, for example. But it remains a big part of the economy. And in the Delta region, is where 99% of all the petroleum mining and pollution. So you can see the Niger Delta is named for the Niger River that flows from Mali, Timbuktu, all the way to the Atlantic Ocean. And there's a confluence with Benue River, which comes from Cameroon. And right now, the capital of the country is situated in Abuja, but it used to be in Lagos. And I was growing up in the western part of the country. And so it wasn't that difficult to travel into the Delta area and try to do some research. But over the years, this has become an international case study for what not to do with fossil fuels, mining, this sort of disregard for ecological destabilization, but also of people. Gas flares and oil shins were frequent occurrence. And at the time, nobody thought of, this was in the early 1990s, late 80s. Nobody thought, blinked an eye when gas flares were just part of how to reduce the pressure in the oil wells. Until, maybe a little later on when people started thinking about climate change and these emissions as part of how we can mitigate carbon release into the atmosphere. But it was a very common phenomenon, day and night, and people living around these parts would always kind of see these flames going on. It didn't take too long for me to start understanding the justice issues associated with petroleum pollution in the Delta. My work at the time was just characterizing the pollution and the impacts on the ecosystem, but the part of the country also was extremely poor. The infrastructure was bad. It was very common for people to get stuck, and we got stuck when I went back, and trucks break down, and it became a really hazardous and dangerous place to travel. But the companies that were doing the mining, Dutch Shell, Texaco was part of the group at the time, but Shell was the biggest of them all. And the protests that came with community activism supported by Amnesty International really became the poster child for, or poster case for my introduction into what I would now call environmental justice. We didn't call it that at the time, but clearly there was the use of the word justice for the Ogoni people, just like we read the sort of acknowledgement of the Patwin land. The Ogoni were very respectful of the natural environment, and it's not just about religion, it's also just the resources that they got for it. And the most vocal person in the community, Ken Saro-Wiwa, was ultimately executed by the federal government. It was a military government at the time in 1995, and this made it a big international outcry. So on that background, I came to the US to continue my studies, but I was very determined to do environmental microbiology and chemistry. And when time came for me to do a sabbatical, I wanted to study what I thought was undervalued aspect of climate change and energy resources. And I went to the Belfer Center at Harvard to talk to them about vulnerability in assessments in the global climate studies that were being done, and the role of disease in in those assessments. And I was thinking that if we were able to understand better how the countries could respond in a way that complements whatever work they're already doing on health, they could easily then add, or relatively easily add, concerns about climate. But the models that were being used did not really address the kind of health issues that I thought were most relevant in terms of energy and pollution. A lot was focused on infectious diseases, right? Malaria, which was already endemic. But what are the other health issues that contributes to the disease burden in those countries? So one of those, of course, was lead pollution. Nigeria had become a giant in um, petroleum mining and supplied, gasoline for most of West Africa and part of East Africa and southern part of Africa before Angola became a juggernaut. But Nigeria also had one of the early refineries of petroleum, and leaded gasoline was used. Uh, and we began to think about a phase out of lead from the refineries and the gasoline used in the country. But we would always get this pushback that, well, gosh, it's too expensive, we can't afford it. So my PhD student at the time, Tim Smith, uh, decided to take this on, went to Nigeria, with CDC equipment, and we managed to get blood samples from many children in rural parts of the country, and estimated the cost, not only in education, healthcare, uh, not being able to walk, and it proved that, in fact, it was going to be a lot cheaper for the country to move to non-leaded gasoline if they were to internalize the cost of lead poisoning for the population. And that was part of the World Bank's push to get lead out of gasoline in that part of the world. Long after the US have done so, of course. But we also had at the time data that we collected with the lead in the blood of children ages 1 to 6, with more than 30% of them in the last column here, um, you know, above 10 micrograms per deciliter of lead. That, even at the time, was considered very dangerous by CDC standards. So a third of the kids were already lead poisoned, but most of them had, males and females, mean blood lead levels, hovering around 10. Um, and now the CDC recommendation is 3.5 microns, where you have to sort of intervene. And so it was safe to say that almost every kid in the country had some level of lead poisoning. And I was not convinced that the level of lead at the time that we were seeing in the blood was actually being reflected by the lead in the recommendations for how to make sure the kids return to a decontaminated environment. So I was doing parallel studies trying to create a biosensor for lead bioavailability. And this enzyme that we used here is phylogenetically conserved. Humans have it, bacteria have it, and humans have a version that there's a polymorphism, and about 25% of the population have a variety that lets them accumulate lead in a higher concentration than others. And this is not found in the African population. And I wanted to find a system that could tell us this variability and how it might connect to different recommendations for different populations. It's sort of a gene-environment interaction type study at the time. And this study about lead bioavailability caught the attention of some of our faculty members in the School of Engineering, particularly my colleague, Julie Shenong, who at the time was, I think she was consulting with the with the electronics industry. Julie eventually came to UC Davis to become, I think she and her husband were in the Department of Material Science. And they returned to Irvine, and I've left now, but this was around the year 2000. And she said to me, I saw your paper on biosensors for lead. Is there a way we can think about alternatives to lead that would be less dangerous for human health? And I said, well, in public health, both lead and these alternatives will probably have health effects, but can you reduce them to cost of healthcare? But if it's a new metal or a new organic material that we don't know anything about, it's very difficult to go to dollar amounts. We certainly know lead is bad, but we don't know how bad the alternatives are. And that began our conversation around alternatives assessment, life cycle analysis. And we first wrote a paper published in the Journal of Industrial Ecology, really thinking about policy differences and knowledge gaps. And this sort of rekindled my interest in how policies don't protect every or the most vulnerable populations, right? Because I already thought a little bit about this genetic polymorphism in dealing with lead exposure, but that if we're going to find alternatives to lead use in electronics, we should not just think about does this new material work for electronics? We have to also think about does it have health impacts that can be avoided, and if not avoided for every person in the population, those who are working to mine the new metal, those who are using it, and those who are dealing with the waste. So we kind of talked about these gaps in the article. I think this team was funded because we came from different disciplines. Julie was in the materials field, I public health. John Daniel Safaris was an economist, although now also in engineering. At the time, he was in the School of Social Ecology in public policy. And Andrew Shapiro now works at NASA JPL, but he was an electrical engineer. And we began, a 2 decades long collaboration on electronics and electronic waste. I probably took the team in a dimension that really started to think more about how the health impacts cannot just be to avoid health impacts for manufacturers, because in occupational health, they knew that exposures to the organics, the cleaning solvents, the trichloroethylene, all those had issues. But I wanted us to think about the poor people who are working under conditions that are not regulated, where we already knew at the time e-waste was going. So our first paper where we talked about what you might consider justice issues today, this was 2009 now, it's old, was a policy forum in science where we sort of played on the word of electronic revolution, if you know that book by the journalist. But It's like from Wonderland, where we're benefiting from a lot of the advances of electronics, to e-wasteland, where they're not exactly enjoying the benefits because these are expensive equipment, but it's a wasteland where we essentially dump the waste. And of course, some reviewers pushed back, but we had we couldn't put a lot of data in here, but we had a lot of information that showed that this is a very fast growing waste stream, fastest solid waste stream in the world. And there are not adequate recycling policies to deal with it. And there were already pockets of uh, villages, particularly in China, Guyu, China, where they just take the waste, the electronic waste, and try to smelt it and get copper, gold, silver with low temperature burning of the plastics and soot and ash contaminating the entire village. But they couldn't care because they were getting small amounts of money from selling the small pieces of precious metals that they got. And colleagues, now I have a lot of collaborators in China, and China has cleaned up quite a bit. But there are still these cottage industries or artisanal mining, we call them, where the blood lead concentration of children still lower than what we were measuring in Nigeria from petroleum products, but still pretty high, 15.3 micrograms per deciliter. And that was, would not be acceptable in the US, and now it's not acceptable in China. But at the time, it was a scandal. But we also knew that it was not just toxic metals, it was polybrominated diphenyl ethers, brominated flame retardants and phthalates and all kinds of things that were present in the ash. And fast forward about 15 years, this has become an international scandal. And the World Health Organization, after a lot of push, finally issued a report in 2021 called Children and Digital Dump Sites, E-Waste Exposure and Child Health. And it's estimated now that at least 18 million children and adolescents and about 12.9 million women who work in the e-waste industry are at risk from adverse health consequences. I have to say there was a lot of debate about the choice of words. At risk implies that, yeah, they're at risk, but we don't quite know what the health outcomes are. And we've always sort of pushed back on, but understandably, WHO really tries hard to please every country. As much as they try to please the US, we still are pulling out. Anyway, Dr. Tedros does try hard, I think, to show how serious the issue is. And he called it a tsunami of e-waste, and that this is at the level, if not more so, than plastic and microplastic pollution, and we really need to do something about it. To his credit, WHO joins the United Nations, other agencies, to have what we call a global e-waste monitor that they publish every year. So the 2024 version is available. You can have access to this slide, so if people want to click on the link, it's possible. But the e-waste monitor, it's like a network of e-waste researchers all over the world that engage government sectors so that it can record sales of electronics every year, and what's being collected, what's been treated, and what's been disposed of into the environment. Not to to make it light, but you can imagine that there are lots of gaps in the data. But one of the non-governmental organizations have contributed, Silicon Valley Toxics Coalition, for example, have put sensors, I think it's called radio frequency sensors, into e-waste, for example, generated from California, and track them to different parts of the world. And it's very clear that despite the United Nations regulations under the Basel Convention that e-waste should not be shipped internationally because it's hazardous, that the movement continues. Part of that is because of the camouflage of e-waste as refurbishable electronics goods. So if you think you can repair and resell your mobile phone, according to the US laws, the US is not a signatory to the Basel Convention, but it technically can be shipped overseas. And like many hazardous things, the net flow is from the affluent countries to the poorer countries where they need the labor, they need the resources, and they don't have strong laws to protect the workers. What I just said, that the international laws consider e-waste as hazardous waste, needed data to support that assertion. And it wasn't clear until the when we were doing the NSF Biocomplexity grant, that you shouldn't throw your mobile phone into the trash after you're done with it, because there were no rules. But California was among the first to make such rules. And this study, Johnny Lincoln was a PhD student who worked with us, and he benefited from the what used to be called the UC Toxic Substances Research and Teaching Program, with headquarters at UC Davis, actually. And it was the first demonstration that, according to US EPA laws in California, toxic substances, DTSC laws, that they are hazardous waste. And so from this study and others, it became clear that we have to regulate them. You have to provide infrastructure for collection and treatment and disposal. But we also knew that when we ship this to other countries where the artisanal miners take control of them to recover their materials, like small amounts of copper and gold, that the ash that remains is very toxic. That work was done in my lab by Kathleen or Charlie Hebert, who then went to work for the EPA. And this added to the life cycle analysis data that we eventually were using to understand that if you can remove certain toxic components in the manufacturing process, it might become safer for those who really need the jobs to manage e-waste. So it wasn't, what Charlie found was a lot of metals, but another PhD student, Jamie Allgood, also showed that halogenated flame retardant chemicals, that we know their signature is specific for electronics. You can find flame retardants in after fires, wildfires, in furniture, clothing, but this category are associated with electronics. And we were able to show that even during use, these chemicals shed, especially when you're using old equipment. But where artisanal miners are working, it's just a huge source of exposure for them. And the electronics industry began a halogen-free electronics soon after that, but that's because of the uh, um, the ozone issue, not because of the human health issue. It was because we really wanted to um, have the electronics industry aligned with the refrigeration industry in getting rid of halogens. Um, and then, we also showed that, in lithium batteries, this was in part because Apple and other manufacturers, it was very difficult to get um, your old phone um, sort of just replace the battery. The batteries were more expensive than the other part of the phone. So people were throwing away phones with the lithium ion batteries. And there was a big revolution also in batteries that were being used from nickel metal hydride to now lithium batteries dominated the entire landscape of rechargeable batteries for electronics. They have their risks, and what we showed was that when they're discarded, they do contribute a lot of lead at the time, chromium, thallium, cobalt, copper, and nickel. We highlighted cobalt because there was already beginning discussion about mining cobalt with child labor in Democratic Republic of Congo, which is currently facing major civil war, in part because of the mining industry there. And the electronics industry was not really paying attention to recovering any resource from expired lithium-ion batteries or defunct e-waste. And we thought that this was wasteful, but also fueling this sort of conflict and child labor. Um, uh, Not surprisingly, the international rights advocates sued Apple and Google and over the Congolese child cobalt mining. I think this lawsuit was uh, thrown out, but it's not the end of it. I personally trace some of the conflict that's happening right now in Congo to the international community not dealing with the situation early enough. But we all benefit from all these products and pushing Apple and Google and Tesla and the lithium ion battery users to pay attention to where where the source these materials is critical. I know a lot of the raw stuff gets shipped to China where they refine and then sell it to the manufacturers, which was the argument the companies used here, that they're not directly involved. But, we know that, indirectly, we're all culpable. We also, another controversial one, when the CRT screens uh, were replaced with flat screens. They first went from the CRTs to fluorescent lighting, backlighting, and then LEDs. So now most of the screens are LEDs, and we wanted to just compare, what that when you a bulb burns out, typically you just throw it in the trash, right? The old incandescent bulb. Well, we all knew that fluorescents contain mercury, but we weren't really sure what LEDs. LEDs are technically electronic products. And so what we found was that, yes, some of the same metals and organics that we would find in any e-waste is also part of LEDs. LEDs last long, but they also can release hazardous substances if they go into landfills or just in the environment. So they should be regulated. as hazardous waste. They're not as dangerous as fluorescent because they don't, they're solid phase. They don't break and release white powder everywhere. But still, at the end of their life, they should be regulated. And this article got uh, a lot of bad press because at the time, the LEDs industry was just taking over. According to US regulations, I think it might have been Obama that, told us we should phase out incandescents. But when we started pointing out that we need to build infrastructure to collect and treat LEDs, we were seeing as either wanting to keep using incandescents, which is not our goal at all, but just to point out that we needed to be prepared for communities that will not be ready. So all of those studies really showed some of the risks associated with e-waste. What became a little bit contentious was, are these chemicals actually having effects on people? So you can look at e-waste processing facilities and artisanal mining um, villages. And this is what we did with my colleague Narendra Singh, now works for the British Geological Survey. And we showed that, in fact, you could link e-waste exposure to adverse pregnancy outcomes based on some of the key chemicals that we already identify that comes with e-waste. And from an epidemiological perspective, if you go to those communities and start doing the sampling, if you have enough power, you should be able to demonstrate what is the most important effect. That study was also kind of building on the uncertainty that was already in the literature that you can't tie e-waste to the health outcomes. Well, now we know you can, but at the time it was pretty controversial. Those who didn't want to change anything just kept saying we should, wait till we have enough data. And I wrote this article saying, we should adopt the precautionary principle here. All of these chemicals are already known to be hazardous. Just because, source apportionment, you can't say they come from e-waste. We know e-waste is adding to whatever burden is already in the population, that we need to take action. And the Basel Convention was a place to have the international community agree on that kind of protective policy. But the US, not being a signatory, powerful bystander, would always object to that kind of language in the Basel Convention. So, I sort of, not that I shifted gears, but I wanted to really understand where to look for these kinds of health effects. And so I began, I already knew that, the artisanal miners, the children who are mining raw materials, that you just have to look and use the best studies methods to get to health effects. Like, lead, you can see children not learning quickly, but it's a lifelong impact on them. And you have to wait, 20, 30 years to see some of the physical health outcomes, but behavioral and cognitive, it's there when you can. And there were arguments, including from the International Labour Organization, that people need jobs, but how can we make the jobs safe for them? So I wrote this article about environmental justice after really thinking hard about where we can intervene, where we can convince in manufacturers, these are the richest companies in the world: Apple, Google, Samsung, Tesla, and we, the people, benefit from their products, but yet we know that the risks and the adverse impacts are not uniformly uh, distributed in the population. I can keep my cell phone with me all day long. I don't feel like I'm at risk of toxic chemical. I may be at risk of, electromagnetic radiation, but I'm not worried about the chemicals until if I'm poor and I'm working in a waste dump, then I am directly exposed to those kinds of chemicals. And that is, we share the responsibility to keep that away. And part of the justice argument is that even when we affluent folks think we're doing a good job, right? There are loopholes. So, about 3 years ago, the state of California sued Walmart because they were dumping, they collect, e-waste, used phones, computers. Almost every home appliance now has electronic components, and they were dumping this in local landfills. And you can imagine where those landfills are located. Right now, we're worried about where to put the hazardous uh, waste from the wildfires in Los Angeles, and most landfills. California doesn't have many hazardous waste collecting landfills, but most of them are in places where people have built around because the land is cheap. And now we're beginning to see some empowerment of those populations and communities saying, no, we don't want this hazardous waste near us. The other topic I covered, and this was extremely controversial, was the use of prison labor for e-waste management. So Unicor is a company, an independent company, pretty much works for the federal government. And they have e-waste collection and processing centers in prisons at these locations in the United States on behalf of the federal government. And it's been shown, I mean, you can go to their website and they have all kinds of assurances, and they have videos of prisoners disassembling electronics. They don't do smelting. In fact, we don't have any e-waste smelting facility in the US at all. So, which is partly why we ship things outside, including Canada, by the way. But when you look at so the testimonials of some of the prisoners that have been in this process and have now come out, you can tell that they have not really been protected. And some colleagues, several years ago, there was a huge expose by Gopal and Aaron on using captive labor for managing electronic waste. And they have, testimonials and interviews with people who show some of the predictable health effects that we would have, we could have prevented if they had adequate personal protective equipment, or including masks and gloves and those kinds of things. So this practice continues, although if you go to the website of Unicor, they do say that they are compliant and everything is done above board, and it's more transparent than it used to be. But that study will continue. I've also had the benefit of collaborating in just discussions with anthropologists who have studied the issue of environmental justice around e-waste. There is a site in Accra, Ghana, called Agbogbo Market, where it's essentially a scrap market, and they get a lot of electronic products that are used, and they try to recover. And when I went there, the river that flows through is just black, lots of trash, but people also sell food. And so you can easily envision a situation that's, there's soot, there's ash, that's not safe. But the anthropologists helped me see some of the challenges around, these are migrant laborers who come from across West Africa, particularly the northern part of Ghana, and they go back to their communities after working, earning some money, and being exposed to lead and other toxic chemicals. And the government, of course, is embarrassed by the situation. So not too long ago, they actually cleared out the space, but with uh, understanding that other risk factors come into the community because people become employed. So it's complicated at these international locations. It may not be complicated to say prisoners in the US should not be dismantling and recycling e-waste, but the federal government and states make money of that. And if they would use that money to reinvest in making it safer, then it would be something that we can maybe not give our blessing to, but understand. So those anthropologists have helped me see some of the complications of using an environmental justice lens to think about these issues. And, we talked about empowering communities, working with manufacturers, not pointing fingers, but bringing them to the table to say, invest in protecting the communities that are stewarding your products. If you don't have extended product responsibility to take back, but at least protect those who are uh, 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 laboring to recycle things. Of course, we've called this the circular economy of electronics. I think there is an opportunity to do better than what we currently do, not just because it's economically sound, but also because it protects people who are particularly vulnerable. When we published that article, we talked about some financial incentives, and the editor published an editorial for Nature Electronics called The Road to Recovery. And, I presented, some of the um, issues that address the justice aspect of it. And I use the word inclusive here, not minding Donald Trump's attack of inclusion, but inclusive in the sense that you have to engage not just the community, but the industry, right? Uh, we cannot say artisanal mining is illegal. We should just make it safer. Um, we have to replace potentially very damaging and toxic chemicals and through green chemistry. And the policies for transboundary movements of hazardous materials, like the Basel Convention, they have to be strengthened and enforced. So we've, I'm gonna go through this quickly, but the circular economy, these are just approaches to what I call bending the curve so that there's no real waste, and through mining, manufacturing, consumer use, and disposal, that it's all closed. We've done a comparison of what's effective, technical or regulatory, or some integration of both. I think that we of course, uh, uh, what's helpful with the technical issues and innovation is that you don't need enforcement. If it works and it's safer, it just takes over the market. Regulatory innovations can backfire, they can have gaps and loopholes. Engaging industry is critical for this technical innovation. And I think Francisco mentioned I co-chair the Apple Green Chemistry Advisory Board. We were supposed to meet last couple of weeks ago. We didn't because Art Fong, who chairs the committee, has been sick. But Lisa Jackson, who used to be a former EP administrator, is really the boss here. And Apple's tried to get rid of some of the notorious metals and organics, but they're very secretive. So we only know what they had. We don't know what they're planning to have. So it's difficult to um, address the needs that way. But they published the first supply chain chemical inventory for their products, and that's very helpful. We've also worked with Microsoft to think about replacing some of the really nasty chemicals in printed circuit boards with bio-based materials that will be easier to recycle, particularly for artisanal miners. And I think that's going to gain some traction. Consumers have to be engaged. We need to repeat this study. This was done a while back in California. People are willing to pay an extra premium for a green phone, for example. When I gave this talk in my class, I would ask whether or not how much people are willing to pay, 1%, 5%, 10%, 20%, or 25%. You can think to yourself, if I were to tell you your iPhone contains no toxic chemical, how much more would you pay for it? Anyway, at the time we did the study, most Californians will pay 5% premium. And we've also tried to encourage linking, as I mentioned at the beginning of my talk, in the intersection of justice issues. We've had this article talk about climate change co-benefits of managing e-waste better. For every phone, actually this applies more to big screen TVs, that if you delay buying a new one for 2 years, you prevent, of course, all of the emissions that come from mining and manufacturing and delivering a new one. And the climate carbon emission benefits are substantial. That article was popular. It was covered in the press, and every December I get a call from some radio or TV station about, oh, people are buying new stuff. Can you encourage them to keep using their old phones and not give the new stuff to their family and friends? And I have to dust off the numbers again and reissue it. But extending the useful life of products is important, but it's also under attack. It's not easy for manufacturers like Apple to see it. This was a case brought against Lexmark. I think they make printers, and they didn't want third party to repair, but the Supreme Court did rule in favor of third-party repairs. Apple relented, but only for certain versions of their products and only for certain parts. In California, of course, we pay a little bit for recycling. So in terms of policy, DTSC, actually, most of you may not know that since 2005, you pay $6 to $10 every time you purchase a video display device. But we have a network of e-waste collectors. The problem is we don't really know for sure what they do with all the waste. So I said we don't have smelters here. And stockpiling is a problem. We did a national survey of people's keeping e-waste in their basements and attics. And then when they move, they throw them out. Or when there's a fire, as happened in Los Angeles, it's all part of the debris and the ash and the waste. And so we need to invest more here to avoid those kinds of risk factors. Goodwill used to be a good collection agency, but there are many things they don't accept. Some of them are overwhelmed. This was me and a visiting researcher from China visiting the Goodwill in Orange County. They do use labor that I think we give them advice about protecting the laborers better. But I think that places like this are few and far between. And we documented that people are willing to travel about 4.5 miles to take their stuff out to a hazardous waste collection center. But beyond that, most people would just rather keep it at home. I'm running late, but I wanted to just share some of the ways I'm thinking about this kind of work. I was part of the uh, Materials Society's, they had a comic exhibition, Super Materials of the Superheroes. And the power they thought I had was to see into the future, time travel. And if we could see into the future of materials like plastics and lead, of course, we will never use them. But there are many things we're doing now that are affecting certain members of our communities that are vulnerable. And I think life cycle analysis, life cycle assessment can help us to some extent. And we've tried to use these methods for future energy and electronic products. This was a grant from California Energy Commission. And, we've published with Professor Kendall, using LCA for emerging battery systems. I think what's missing is how we can include things like environmental justice issues. I don't have a lot of experience with social life cycle assessment. I know UNEP and the LC initiative are trying to grapple with this, but I haven't actually used it in my studies. And that's something that I'm hoping to do until I know that this administration probably impossible to get an NIH grant on that. So this is, I guess, the most recent article from that study. I think as we think about maybe replacing lithium-ion batteries, but there's a lot of stockpiling, and you all know better than I do. But everything now is electronic, your car, everything has to be taken into consideration from cradle to cradle, as they say. So I want to thank you for your patience as I went fast through some of the topics that I promised at the beginning. But I hope I've shown you how I started with the petroleum industry in Nigeria. And that got me into my microbiology of lead sensor to see that we can have different, or standards that protect the most vulnerable children from lead poisoning. And that biosensor led to my invitation to join material scientists who are struggling with how to get rid of lead from electronics, and all the work we did to think about artisanal mining of e-waste to get the information about what are the chemicals that cause damage and what can we do about it to reduce the injustice, working with industries, working with communities, and um, seeing into the future when we can. So thank you again for your patience. I think we have a few or 20 minutes to have questions and conversation. Thank you very much.
All right, everybody, please join me in giving Professor Dele a round of applause, a virtual round of applause. I would like to, well, first of all, thank you so much. That was fantastic. I would like to now open it up for questions if anybody from the audience has something right away, or if not, I can start, but I'll give people a few seconds to react. All right, I'll kick us off. So this is a student-led webinar and effort, right? So thinking of that, our first question is kind of related to that. And so what are we as energy researchers missing? You know, what would you like to see more in our curriculum or our efforts being focused on?
Thank you, Francisco. So when I joined UC Irvine, it was a School of Social Ecology, and this was exactly the kind of question that I will always get from students. And because students will come from either a social sciences background or typically environmental science, maybe even physical science background. And the idea of social ecology was to get them to work together, to identify really strong problems that society faces and bring the methods from the different disciplines to bear. Now it's called mixed methods, right? So when I talked about social life cycle assessment and going beyond the toxicity of lead. It's like I always ask myself, why do we still keep using lead in many products, right? It's despite hundreds of years of history teaching us that there's no real safe level of lead. And we would always get convinced that, well, it's not going to be, you're not going to be exposed. Somebody just showed me in my mug that at the bottom of it is a lead solder. It's, if you see a little bump at the bottom, it's probably lead solder underneath. So while I'm drinking, it's okay, but eventually most people would just throw this out, and the cycle repeats. So I think I'm not saying that students should not focus on their strengths. I think we all do, but being open to collaborate or learn methods that are outside your discipline, but can contribute to the answers that are really meaningful. I think that's important. Faculty members and researchers also, we build on our strengths, we play on our strengths, but it's easier for us to collaborate as faculty members than it is for students to collaborate. So students, you have to learn the methods that you need. But being open to that when you get recommendations and suggestions from your committee, which hopefully are not all doing exactly the same thing. I think that's one way to think about it. I think UC Davis has a better environment for graduate students through the graduate groups to do this sort of interdisciplinary work than other universities in the UC system. For us in public health in Irvine, we still say the committee is, public health and maybe one external member who is not an expert at all. And so, I think it's a bit narrow in the way we do the curriculum for the PhD dissertation on my campus anyway. But increasingly, the kinds of problems that interests students are multi-dimensional, multifaceted, and multidisciplinary. And we have to be able to break that down in the way that they see their contribution being part of that big picture.
Yes, I agree. Thank you for that. Okay, I have, oh, good. We got one in the chat. It says, thank you for your talk. My question is outside the energy field. I am a lecturer in biochemical engineering at
Berkeley?
UC Berkeley. I'm curious what role you think bioremediation
Ah,
might play in e-waste recycling. Okay.
yes. Yeah, that's an excellent question, Francis. Uh, I didn't in preparing talks like this, it's like, oh gosh, what should I leave out? So I came to California from Tennessee um, on a bioremediation project. I was working in a way to remove mercury from sediments in the Oak Ridge National Labs. And then I got a grant from Electric Power Research Institute, EPRI, in Palo Alto, and came to California. So, I mentioned the use of mercury in fluorescent, and the mercury is present in electronics, and it hasn't been phased out despite the Minamata Convention on Mercury. Um, and so there are certain aspects of electronics where you can use bio-leaching, the same way you do bio-beneficiation of minerals. You can bio-leach metals from e-waste, and it's a well-tested methodology. So it is quite possible to use bioremediation um, for e-waste contaminated environments, but we also want to use it before contamination happens to recover resources from used electronic products before they become hazardous waste that's in the environment. So it is a vigorous area of research that's borrowing from mining, but it's not yet profitable, unfortunately. We have a paper last year that compared bihydrometallurgical processing um, uh, and pyro, metallurgical processing. And yeah, burning is still a good way to remove and recover metals. Just the rate at which the biological processes work is a little slow. But as a bacteriologist, I can assure you that there are bacteria that can do this. We just have to make them do it fast and do it well. I hope, yeah. Thank you, Francis.
All right. Carissa, you had a question?
I do, yeah. Shifting a little bit to policy, I was curious about what you think legislators should be advancing specifically when it comes to e-waste, or like thought of, if you think about the question a different way, if you had the ability to write one bill or one law tomorrow, whatever
Yeah.
you wanted, what overlooked aspect of this e-waste management topic would you prioritize with that?
I'll give the quick answer and we can say more. It's to get the US to become a signatory to the Basel Convention. Okay. Because this will never happen in this current administration. Let me just say that. I mean, they're but you can't do this alone, right? So even within the US, there's another talk I gave just on the policy gaps in e-waste regulation in the US. Massachusetts and California tend to lead the way, don't throw e-waste in your trash, will incentivize collection and dismantling and all of that. In between states, what we hopefully not disparagingly call flyover states, actually you can probably put in red and blue states, it's a different story. It's not seen as a problem, but so we have these gaps within the states. If we had strong leadership at EPA talking to legislators in DC at the federal level, we could really avoid US e-waste going to other countries. What that means is it will then invest in how to do it properly in the US, right? And so the Department of Energy recently realized that, oh, we need rare earth metals, we need critical metals, right? So they issued a call for how to get critical metals from e-waste. And one of my students, Miriam Ibrahim, we responded, and she's working now on using cryomilling to get critical metals from e-waste. It's going to be a high-tech solution, maybe not cheap, but it's something the US can afford, right? But we won't do it unless there's a policy incentive saying, you need a stockpile, you need enough collection, you need enough raw materials to do this kinds of high-tech processing. But when we still have, it's like a basket weave. It's just leaking out, and we can't collect it enough to make it a profitable business. So that would be, a signatory, which means it's illegal to ship it out. Then we deal with it here, and we'll do it safely. I mean, it will still be poor people in maybe poor neighborhoods, but we know enough if we're building it from scratch to protect people and to do it properly in good facilities that are under good regulation of safety and health.
Thank you. Great insight.
Okay, does anybody else in the audience have another question?
I know it's not quite Friday, but it's close.
All right. I have a lot of questions,
Okay.
so I don't mind. Okay, I'll save this one for last because it's a good one. So speaking of leakage, you just mentioned like a basket of leaking waste. A key issue in the trade of used vehicles, which is what I focus on, is that degraded batteries are being exported to lower and middle income countries via the vehicles. They come in the vehicles because they're used and they're traded. Whereas if shipped separately, this wouldn't be allowed per the Basel Convention. Right? They would restrict the trade. How do you think the Basel Convention could be strengthened to address this loophole?
Yeah, so when I've listened to some of the debates in the Basel Convention, actually for e-waste, it was really all about informed consent, right? Just make sure people know the risks. There's another convention that I've worked on for asbestos, right? And asbestos is kind of similar. There are countries that mine it and sell it, and those that say, we're going to buy it and use it. And Russia would always oppose just the informed consent part. And I said, let people make their minds, but let them have the information, right? So there are many risks with lithium-ion batteries, including, fires, and I think we're beginning to see that with the fires in Los Angeles and the cars that make fires very difficult to extinguish. If we're able to separate the cars from the batteries, of course, the market for the second-hand cars will shrink because they're counting on at least the car being able to drive it from the get-go. But part of that is also how they're manufactured. But there's no reason not to be able to, let's say we have a way to affordably separate the batteries, remanufacture them in a way, and sell them separately from the used cars. There's no, the metal and the plastic parts of the cars will last a lot longer than the batteries. So we need a way to be able to sell the shell and a refurbished battery, right? Then it makes sense for the buyer. And you can circumvent all of the hazardous waste Basel Convention restrictions, right? So I think we're still, I know that there are many companies that are working on reclaiming and remanufacturing spent lithium-ion batteries, but I don't know to what scale. That you may know that better. But if we can do that efficiently, then there's a separate market. And when you're shipping, working batteries, it's no longer under those restrictions, and the car can go on its own without the battery. But at the end point, you put them together, you create jobs for everybody. Right now, it's complicated because they're linked. Yeah. Anyway.
All right, I got one last one. Well, we have a lot, but this I say for the end. How do you foresee the landscape changing under the current administration? And dare I say, important shift in public opinion, which may be even more concerning.
Yeah, I think I've had many meetings this week because my USAID grant was pulled, and but so I think I would like us not to give up. I mean, I see people actually complying with things before the executive order comes, or thinking that, oh, we have to not do X. And I say, well, especially in the public health, if we really value what we're working on, right? If we really think that's the best science, we shouldn't walk away from science. Or, it's like, yeah, I know 4 years is not a short period of time, and there will be a lot of changes, but I think in the history of human societies, we've overcome such threats, right? But most of it is to instill fear and uncertainty. It's not my place to try and guess what their end goal is, right? But if we start caving and I mean, there is common sense. I mean, beyond somebody just, or a group of people just wanting to get all the benefits for themselves, there's something about common sense solutions, right? We all face, let's just pick climate change. Like, if we all face the issue, and we all should invest in better energy efficiency and no waste of resources and healthy population. But if somebody has it on their mind that they're going to escape to Mars, right? They couldn't care less. And that's where we want to draw the line. Nobody's leaving this planet. So that, common sense solutions will prevail as long as we don't let them leave.
I agree. Let's keep in here.
Yeah.
All right. Well, it's 4:30, so we need to let everybody go. But we really appreciate you taking the time today, and I hope we'll keep in touch.
Yeah, congratulations again on your group's efforts. I enjoyed the questions, and if there are more, email me. It's easy. Thank you very
Awesome.
much. Okay, enjoy
Thank you,
it.
Professor.
Thank
Okay.
you.
Okay, take care.